So in the last week, I've fielded multiple questions about 12 millimeter oil pumps, and or just running a larger oil pump in your Subaru in general. It's not always a good idea. In fact, it's rarely a good idea. And so here are some reasons why. First off, the Subaru oil pumps don't have a flow problem. They don't. They flow plenty. What they have is a relief problem and a pressure control problem. And the pressure control problem is based on the design of the relief valve. So here's a pump. And this pump here is a newly manufactured pump by a company locally who thinks that putting 12 mil oil pumps in every engine they produce is a good idea. And all I know is that they're going to have a lot of bearing failures. We did lots of, we'll just stick bigger oil pumps on stuff all the time in our airplanes, and found out that we definitely spun way more bearings with bigger oil pumps than before. So why was that? Well, two reasons. One, the relief. See this little guy right here? This is the tube that houses the relief. And that's inside, you can see the discharge hole right there, a little small hole there, this discharge hole, and the pressure side is the hole right there. Okay? So when the pressure goes up, it compresses a spring, and the valve opens up and dumps oil from the high pressure side to the suction side, this big area right here. Let me change hands here. Right there, that's the suction side. So that's the relief discharge. So where does the oil go? Well, it literally goes from one side of the pump to the other side of the pump. So the same volume of oil gets circulated in the pump. And in here are some gears, and so the oil gets sheared and sometimes even aerated and all kinds of stuff that you don't want to have happen. A lot of modern pumps are designed this way because it's compact and it's cheaper for manufacture, but it's not the best way to do it. It's just a cost-effective way to do it. So now what happens? Well, why does Subaru have a relief problem? Not just in where it's located, but also in how it senses the pressure. So in the case of the Subaru oil pump, and I think GM's as well, the spring is housed on the back side, and it is on the same side as let's see, what's that over here, which is the low pressure side. So the spring is back inside this column, and it's part of the low pressure side. And this looks really silly, holding the phone in one hand and the oil pump in the other, but I'm trying. Okay, so I depicted that by this picture here. Spring and valve. All right, so high pressure oil is here, and it goes past the set point and pushes the valve open and dumps over to the suction side of the oil pump, which is also depicted by the oil pickup. Now, this is important, because what that means is that this spring and the pressure across this valve is what dictates when the relief opens. So at low speeds, or I say medium speeds, like 3,000 RPM or so, the oil pressure you'll see on your car is usually right around this relief set point, 85, 95, 105 PSI based on which oil pump you have. But then as you increase RPM, you'll see the pressure drop. And so people automatically assume it's because the oil pump isn't keeping up, but that's not true. What it is this oil in here has weight. And as you pump oil out of the pan faster and faster and faster, this level here drops. Okay? Now this level drops, you are now lifting a bigger column of oil, as I show here. So now I'm lifting a column of oil that's this tall versus a column of oil that's only this tall. Because the way pressure, fluid, height works, the amount of oil you lift doesn't matter the length of the tube, it matters the difference, right, in the height on the other side. Because this here is going to push down, and it's going to equalize the oil in this tube at this point. Where here, it's only going to push down and equalize the oil this far on the point. So now I'm lifting a heavier column of oil. And so to lift a heavier column of oil requires a lower pressure to do so. That lower pressure is felt on this side of the relief valve. And so as you pump more fluid and lower the level in your pan, you are now increasing the differential pressure seen across this valve, and you basically, for lack of better terms, suck it open, at a lower set point. So the RPMs increase. This relief sees the pressure here at the top of this column, this lower pressure that's needed to lift the heavier column, and opens up at technically what is a lower oil pressure than what you would think that it should open up at. Or if it's at 85, it's 75, whatever. And as RPMs go up, this column drops, and the speed at which you're moving the oil also creates losses, right? Now you're trying to suck oil around corners up a tube that's got, you know, 2 angles in it through a certain size orifice, right? It takes more energy to move a viscous fluid through a tortuous pathway. I mean, you can look at this thing right here and see it goes in up a tube, through the block, around a corner, and in this big open space, and then from this big open space up inside this tube over here. All right, so it takes a lot of force to move oil through that tortuous path, and that force is seen as a low pressure region here, which draws open the relief. Okay, that's why oil pressure drops as RPMs increase. That's the main one. There's lots of other small reasons, but that is the biggest reason why on a Subaru, as you increase it, you heard it. Now, what does that mean for a 12 mil pump? Well, if my engine is only consuming a certain, or only needs a certain amount of oil, then my relief is open a lot more. So now I'm circulating more oil in here, I'm heating up, aerating more, whatever. Now, if I happen to somehow force more oil through the motor, well, that means that more oil is going to be sitting in the heads, so it'll take longer to leave the heads, drain down into the pan, and that means this level is going to be even lower as I pull more oil out of the pan at a faster rate. So now I'm overheating my oil, I'm shearing it more in the relief because it's been constant cycle in the pump, and a larger volume of it because I'm wasting more. And if I somehow have an engine that's so sloppy, you know, in clearances that actually need a pump of this volume, then what that means is I'm pumping a bunch of oil to other parts of the engine, and I'm lowering this down again, which also hurts pressure. So a bigger pump is not the answer, especially not 12. That's just way too big. It's just not the answer. Get the engine built right, have the right bearing clearances, so that your oil demand isn't increased greatly, and a 10 mil pump with a shim will work wonders. The shim helps combat the lower pressure that's created by lifting this big column of oil and moving a lot of oil at a high rate of speed or high volume. Thank you.